Welcome back to a 5-minute teardown. Here we have an LED lamp which started to flicker. Let's see if we can open it up and see what's inside. Click! Click! Bing! So I'm going to go back together again. So aluminium PCB with the say 5 diodes, LEDs. Not a lot of heatsink compound on there, and they don't want us getting in there, do they? Will it focus? That's well gunged in. So bit more cleaning up, and maybe we could have a look at the circuit. Well, here we have it big Clive style. The top board picture has been inverted so that it's the same way around as here, and we can see that there is a fuse on the mains input on the live side. Well, it says it's live up here, and bridge rectifier, and then we have the ground path and the live path. And so we'll bring in the circuit, and this is Bright Power's circuit. Right, here we have the Bright Power typical circuit, and see bridge rectifier, bit of filtering, the supply dropper to provide the VCC voltage for the chip, and then we have current sense resistor, the current sense resistor, the inductor and the diodes. And then we'll bring in the actual lamp circuit because they've made improvements on this. Right, here we have the lamp circuit from Neolux. And I suppose here it's not individual diodes, it's a bridge rectifier. But in the red is the main changes. Where Bright Power just had the supply decoupler here, for this design they've moved it to this side and they've brought in a 2.2 millihenry choke with a 1K5 resistor across it, and that's obviously going to stop switching noise going back into the mains. So they've gone one step further than the typical circuit and they've added some noise filtering, which is a good move. Too many companies just copy the typical circuit and don't go the extra mile of filtering things. And in the lamp there are 5 LEDs and the voltage across each one is about 5.8 volts. And then looking at the current consumption of LEDs, the peak current is determined by the threshold voltage here. So it's typically 400 millivolts is the kind of turn off voltage here. 2 R4 resistors in parallel, so we got, actually that's wrong, that should be 1 R2, can't divide, but I think the maths is right. 400 millivolts divided by 1.4 ohms is about 330 milliamps peak. So that's the peak current flowing through the diodes. So I hope you found that interesting, and I'll catch you on the next one.